Hi, Rob here with MIDI Shape Shifter, and in this video I'm going to give a quick introduction to what MIDI Shape Shifter is, and also demo a couple of the many things it's capable of doing. So MIDI Shape Shifter is a fairly general purpose MIDI plugin. You can do MIDI mapping with it, you can transform MIDI data, and you can even generate MIDI from it. I used to use a lot of different utility MIDI plugins that all had one specific purpose, so a big goal for this project was to consolidate all that functionality into one plugin. It's not only free, but also available in any VST compatible host. So there's a couple things that MIDI Shape Shifter isn't great at doing, like step sequencing or arpeggiation. But other than that, it can do just about anything. And to demonstrate just how versatile this plugin is, at the end of the video, I'm going to use it to transform a MIDI control surface into a game of pong. So stick around for that, but for now, let's get started with a simple example. So this is MIDI Shape Shifter. And let's say you want to transpose your keyboard up an octave. In other words, you want to map any incoming note to a note that's an octave higher. To do this, I can create a new mapping by clicking here. This is the mapping view where you can create and edit mappings. A mapping will essentially just transform a range of MIDI messages into a different range. I want this mapping to apply to all the notes on my keyboard, so I'll click the Learn button and press the lowest note on my keyboard, followed by the highest note. And that'll automatically fill in the form for us. Alternatively, we could have just entered it in manually. Now for the output range, I want it to be 12 semitones higher. So I'll just add 12 semitones, and now when we click OK, our keyword should be transposed up an octave. So here it is before, and here it is after. So that wasn't too hard, but let's say you want to create a velocity curve. There are several ways we can do this. The graph on the right shows how the input velocity will be mapped to the output velocity. Right now, the input velocity is not being modified. We can click the graph to add a control point and drag that around to adjust the velocity curve. When we drag it down, the velocities will get quieter. When we drag it up, the velocities will get louder. Now this is a pretty common task, so there are some preset curves. If we select the compressor preset, we get a fairly standard compressor setup. Instead of dragging around the control points, you can interact with the compressor from the threshold knob, the ratio knob, and the gain knob. And the cool thing about these presets is that they're totally configurable by you. You can edit the existing ones, create new ones, and even edit how these preset knobs work by right-clicking them and selecting Edit. Another useful preset for creating velocity curves is the power curve. As you can see, we can interact with this curve using the preset knobs. But if you take a look at this box labeled y equals, this is showing us the actual mathematical equation used to drive this curve. Now the control points and presets have been added so you don't ever have to touch the equations if you don't want to. But if you want to do something really advanced or just like playing around with this sort of thing, then it'll really open up a world of possibilities. What this equation is actually doing right now is just taking the input and raising it to the power of whatever's set on this slope knob. Although MIDI numbers usually range from 0 to 127, the input and output of this graph will always range from 0 to 1. So if we want to add a little bit of volume, we can just add 0.2 to the end of this equation. We can also add control points to break the curve up into multiple line segments and edit each one individually. Combining these two techniques will really let us create any kind of curve imaginable. Although a curve like this wouldn't be very useful as a velocity curve, as we'll see in the next demo, the transformation curves can be used for many different things. So in this demo, we're going to do something a little more interesting and set up some sidechain compression. If you haven't used sidechain compression before, it's usually used to compress everything except the bass drum every time the bass drum hits to make the beat really stand out. The first thing we're going to need is a generator that will generate the dip in audio levels when the bass drum hits. I think we'll want it to last for about 1/8 of a bar, so I'll set the period to 1/8. We don't want the generator to loop or start running right away, as it should only run when the bass drum is hit, so I'll disable the loop and enabled fields. Next we'll need to set up a mapping that makes the bass drum trigger this generator. For the input, I'll just set the channel and note number for the bass drum, and for the output, I'm going to select the generator modifier message type. This message type will turn on the generator every time it receives a velocity higher than 0. We need to map the output of the generator to the host, so that it can control the volume of a channel. So I'll create another mapping which maps our generator to some CC number. I'm going to add one more mapping which isn't totally necessary, but it's going to filter out all of the MIDI notes coming from the drum beat so that MIDI Shape Shifter is only outputting this one CC message. So I'll set the channel range and parameter range to all, and set the equation to the keyword ignore, which essentially just tells MIDI Shape Shifter to not bother outputting anything. Now, one thing to note about Ableton Live is that it won't let you map the output from a channel to a parameter. So we have to map the output from MIDI Shape Shifter to something like MIDI yoke, which will then just loop the MIDI back into Ableton. So if we play the beat, we can hear that the piano and synth are coming through this channel. So this is the one we're going to want to compress. So if we map the CC coming out of MIDI Shape Shifter to this channel, we can see that the bass drum is now driving its volume. We still have to play around with the curve a little bit to get it sounding like sidechain compression. With a normal sidechain compressor, this is about all you could do, but by playing around with the curve a bit more, you can really start to get creative. I thought it might sound interesting if instead of compressing the audio, the bass drum kicked off an LFO. There's an LFO preset that's great for creating all sorts of LFOs, so let's see what that sounds like. It sounds a little bit too fast right now, so we can double the length of our period, and just play around with these preset knobs until we come up with something we like. Before long, you'll be able to come up with something that's pretty unique and nothing like what you started with. At the start of this video, I said I would use MIDI Shape Shifter to create a game of Pong. So here it is. I'm not going to go into a lot of detail into how it works, seeing so it's probably not something you're ever going to need to use. But basically, it's just going to use the outer two faders in my MIDI control surface to represent the paddles in a game of Pong, and the inner faders to represent the ball. So here it is in action. To start the game, I can just press this knob here. I can control this fader on the left, and there's an AI controlling the fader on the right. The two rows of buttons at the top are keeping track of the scores, so you'll see an LED come on whenever someone scores, and first to 5 points wins. This is about all I have to show for this video, so if you want to get more info on MIDI Shape Shifter or download it, then check out the website. If you have any comments, questions, or suggestions on how to make MIDI Shape Shifter better, then let me know at the user group. Alright, till next time.